Hello everyone. In this session we are going to talk about sound absorbing material, or we can say absorbents. Okay. So there are different types of sound absorbing materials that we are using in our daily lives, or they are used and they are categorized in different category, and they are used to have a good acoustical hall, right? So sound absorbing materials are used to prevent sound from being focused or being concentrated at one point. Okay, sometimes what happens, sound is being concentrated at a particular area. Okay, so sometimes due to interference phenomena, right, if it is constructive interference, then sound will be maximum at a particular area, and if it is a destructive interference, then sound will be minimum at a particular area, or sound will be dead, right? So what happens, sometimes due to curved surfaces, what happens if the phenomena of interference occurs, such as constructive or destructive? The direct sound waves and the reflected sound waves are same, right? If they are in phase, then it is said to be constructive interference, otherwise it is a destructive interference, right? So all this type of problem of focusing and interference, sometimes what happens due to multiple reflections in some places, right? Due to there are the reflecting surfaces, there are rough surfaces in the room. So due to these surfaces, there are the loudness is inappropriate, right? Sound should be adequate and appropriate in every corner of the room, right? So we should try to make even sound propagation in any hall or in a particular room. Okay, so to have a good acoustical hall, right, we need to know about some absorbing materials. Okay, for example, let us first start with porous absorbance. Right, porous absorbants or porous sound absorbing materials are the materials which have tiny holes or pores, we can say, in them. Okay, so whenever sound strikes the surface of a porous material, a part of sound waves get absorbed by the material, and the part of sound waves is being reflected. Okay, so the sound wave that is reflecting from the porous materials is then converted into heat. Okay, right, so this is known as porous sound absorbing material, in which whenever the sound wave strikes the material, a part of waves get absorbed by the material, and the part of waves is reflected back from the material, which is then converted into heat. So this is known as porous sound absorbing material. Okay, so the rock, wood, wool, glass, silk, etc. These are the types of materials. You must have seen these materials in the staircase, or being used, or they are being used as curtains on the windows, or they are even used on the walls, right? So sometimes in theaters you must have seen that walls are being covered by porous materials, and even seats are being covered with porous materials, and even the staircase is being covered with the porous materials. So they are the best sound absorbing materials, right? And they are the most useful, most commonly used, widely used porous materials, conventionally used porous sound absorbing material, right? So it is the most generally used sound absorbing material, which absorbs part of sound energy, and part of sound energy is reflected from the material, which is then being converted into heat energy. Okay, let us go now to the next sound absorbing material, which is cavity resonator. So we know that what does cavity means? Cavity means a small chamber, a chamber with a small opening, we can say, right? A chamber with a small opening is known as cavity. So what is cavity resonator? It is a chamber with a small opening for sound waves to enter, and when sound waves enter the chamber, the waves get the waves enter the resonator, and due to multiple reflections inside, the sound waves are absorbed inside the cavity itself. Okay, inside the chamber itself. Right, so cavity resonator is basically a chamber with a head that is having a small opening for the sound waves to enter the resonator. So whenever the sound waves enter this chamber, due to multiple reflection, it remains there, right? The sound waves are being absorbed by the cavity. So in many areas, in offices or in staff rooms or in classes, there is a in the backside of the hall, there is some air conditioning plant are being used, right? So this air conditioner plant machine or machinery is known as cavity resonator. Are the examples of cavity resonator. Okay. So in which there is a small chamber for sound waves to enter, and when sound waves goes there, right, due to multiple reflection, it remains inside this chamber. So these are cavity resonators. Now resonant absorbance or panel absorbance, right? They are also known as panel sound absorbing material, or we can say resonant sound absorbing material. So first of all, we know that resonance means matching of sound. Okay. So what does resonant absorbance or panel absorbance mean? Okay, so now let us talk about resonant absorbance or panel absorbance. So what does resonant sound absorbing material or panel sound absorbing material means? So whenever the absorbent material is fixed on a framing with an air space between the framing and the wall, the sound waves strike the panel, and due to the flexural vibration of panel, certain amount of sound energy is absorbed by the panel, which is converted into heat energy. So you must have seen the window panel, right? If we talk about any window panel, there is a framing of the window with an air space. Okay, so in this air space, when sound waves enter the strike the panel, so due to the vibration of the panel, certain amount of sound energy is absorbed by the panel, and then it is converted into heat energy. Okay, so windows, doors are the examples of resonant panels or panel absorbance, and gypsum boards are being used in many rooms, right? If you want to have a recording room or if you want to have a sound insulated room, then gypsum boards are fixed on the walls so that resonant absorbance can be made, and this type of sound absorbing material absorbs good amount of sound energy, right? So you can have a sound insulating room. Okay, so the absorbent material is basically fixed on a framing of a window or a door or a wall, right, with an opening with an air space between the framing and the wall. So what happens whenever the sound waves strike the panel, due to the flexural vibration of the panel, certain amount of sound energy is absorbed by the panel, which is converted into heat energy. Okay. Now windows, doors and gypsum boards are the examples of resonant absorbance. Okay. So the last but not the least, the final sound absorbing material is known as composite absorbers. So this absorbance is basically a single unit which does the function of all above three absorbing materials. Right? Again, I am repeating that composite absorbent is the single unit that does the function of all three sound absorbing material: porous, cavity, as well as resonant sound absorbing material. So it basically consists of a perforated panel fixed over an air space, right, containing porous absorbent. So when sound waves strike the panel, they pass through it and damped by the resonance of air in cavity. Okay, so a composite absorber is a single unit that does the function of all three sound absorbing material. So as you can see, a panel is being used, right? So there will be an effect of resonant sound absorbing material. Then porous absorbance is being used over an air space between framing and wall. So sound will be absorbed more, right, than resonant sound absorbing material, right? And there will be the sound that is striking the panel. When they pass through it, they will be damped by the resonance of air in cavity. So the cavity resonator effect is also there. So in this way, composite absorber is the sound absorbant that does the function of all three sound absorbing material. So this is all about sound absorbing materials. Okay. Thank you.